Okay guys, question 11 gives us the information that we got an output voltage and it gives us the input voltage. Okay, it tells us the input turns, and the first question is calculate the number of turns required on the secondary coil, assuming it's ideal. It's money for jam. So basically Vp over Vs equals Np over Ns. Plug in your values, or you could probably better do the other way around, but that gives us, when you solve for that, that gives us 6,956 turns. So that's pretty straightforward there. Okie dokie. Now the question, the interesting one about this is the transformer suffers eddy current losses, and it wants us to explain how eddy currents arise. Now there's a number of points we can make about this, but here are the four I'm sort of thinking you need to go for. Obviously, the changing current in the primary coil causes a changing flux in the core, and it's the key thing here is it's not really to do with the flux or the current, it's the changing current and the changing flux. Second point, if we've got a changing flux, whenever we have a changing amount of flux in a core, we're going to get an EMF induced within that core, and that's the key thing. It's, of course, within the core itself, the flux is developing, and so we're going to get EMFs induced. Now, those EMFs are going to induce eddy currents, and the eddy currents are going to oppose the development of the flux, which is therefore causing inefficiencies. So if you think now, if I just sketch over here, here's my core, let's say it's a simple core shaped like that, and I put my primary coil there, and as I switch the current on, it induces a flux in the core that's going around that way. If we then just take a quick slice through this section right here and just think, well, what would that look like? Let's just draw that over there. And let's say we're looking at it from this side here. We could say, well, as we look at this, there's flux trying to develop, trying to go through the core in that direction, going into the core. Now, as a result, when we've got flux going into the core, what the core is going to try and do is develop eddy currents that will oppose it. Okay, so if we think about this, we just quickly draw my little sketch. There's my north and there's my south. Okay, if the south pole, if the flux is going into the page that way, we're basically looking at a south pole. So what's going to happen is they're going to develop eddy currents in the core here that's going to try and push the flux that way. So we're going to get eddy currents which are going to spiral around in this direction. Okay, trying to oppose this flux being developed in the core. Now, the way we get around that is if we laminate the core with lots of separate little bits, basically sandwiches of iron separated by an insulator, a thin plastic or coating of some sort of insulator. Then of course we can still get little micro eddy currents in it, but we can't get any big bad boys spinning around the whole thing like that. And that's how we have tried to avoid those. Okie dokie, there we go. That's the answer to question part 2. The key is this laminated core. By laminating the core, we reduce those eddy currents.